Our session is about architecting storage DRS data store clusters. Basically, we're here to tell you about the impact of introducing a data store cluster in your environment. And you've all seen this disclaimer, so we're not going to read it out for you. So basically, we're going to highlight storage DRS for you, talk a little bit about the data store cluster construct, tell you about how it impacts virtual machine configuration, talk a little bit more about load balancing, and finally, we're going to highlight the interoperability of with your array. My name is Denneman.
And I'm Valentin Hamburger, and let's get straight into it. So as Frank said, it's pretty early, even for us. So just a short notice. So what is it if you don't have storage DRS in place? What is the typical task looking like when you place a VM in your environment? Like normally, you go into vCenter, search for data store, open the data store, look how many VMs are on this data store, maybe 20. Then you go to the next data store, open the data store, maybe there are only 5 on the data store. So you think that's a perfect match, I can place my VM there. But think about how is the VM interacting with other VMs on this data store? How about I/O performance? How about all the other interactions a VM can make on a data store? So these are things storage DRS is going to solve for you. And we want to highlight how storage DRS is going to solve this problem.
Can I interrupt?
Sure.
So, by the show of hands, how many people are already using storage DRS?
That's great.
Cool.
And how many of you are going to use storage DRS?
Okay.
We ask
Good.
this question again after the session.
Yeah.
All right. So we want to highlight especially the 5 key features of storage DRS, and we are going to dive right into them within the next slides. So the first thing is resource aggregation. So I'm pretty sure many of you have more than 5 LANs or 5 data stores in their environment. So it can be pretty challenging to pick the right one because you have to scroll through a lot of data stores when you place a VM. Now with storage DRS, we are abstracting those volumes, those data stores, into a so-called data store cluster, which leads to a smaller scale decision. So you just have to pick a data store cluster. On the other hand, if you need to expand your infrastructure by adding data stores to your environment, this is also kind of easier because you just add it to the cluster. So storage DRS is about simplifying the process of placing VMs and handling your storage capacity within your environment.
So one of the primary examples for resource aggregation is basically a single point of management. So we have a lot of customers that have 2 teams. One team that is responsible for the architecture itself, like adding data stores, adding hosts. And there's another team that is responsible for provisioning virtual machines. Now, in the old days, before storage DRS, when you add a data store, you had to inform the team that provisioned virtual machines, and then updated Excel spreadsheet, and then you will see the provisioning team that they need to include it in their operations as well. With data store clusters, the team that's responsible for the architecture just place a new data store in your data store cluster. And this doesn't change the operation for the provisioning team because they only select the data store cluster when they want to provision a virtual machine. So now you as an architecture team can add and remove data stores on the fly, right?
Yeah, and it will use, as soon as you place a VM, it will place it on the newly added data store without any interaction.
Correct.
Yeah. Now, we mentioned initial placement, so this is really one of the coolest features, I think, of storage DRS. So when you place a VM in a data store cluster, it automatically selects a data store with the highest amount of free space and the lowest amount of I/O load. So by the initial placement of a VM, it already takes care of leveling out the cluster, like have the cluster balanced. When I say cluster, I mean the data store cluster. So initial placement really enhances the way of placing VMs, and like Frank said it's a single-click management, and you don't have to care about where I should place the VM and if it's the right data store to house the VM in terms of I/O load. Now let's have a look at the maintenance mode, data store maintenance mode.
Yeah, so maintenance mode is quite similar as host maintenance mode, provided by DRS. But in this case, we're going to offload a data store for you. So when you place a data store into maintenance mode, Storage DRS will take care of the storage vMotions of all the virtual machines on that data store. So you don't have to worry about the lead times of storage vMotions and have to check every time when a storage vMotion is complete. One of the primary use cases for maintenance mode is array migration. So create a data store cluster of data stores of your new array and select a data store from your old array, put it in your data store cluster, put that data store into maintenance mode, and allow Storage DRS to find space for the virtual machines on the new data stores of your new array. When that's complete, remove that data store from the data store cluster and just add another old data store from the old array to the new data store cluster, and then do it again. So this will save a lot of time because you don't have to monitor your migrations anymore, right? Now, load balancing is, I think, the most popular feature of the DRS family. And where in DRS we balance on CPU and memory, Storage DRS balances on I/O load and space utilization. Now, Storage DRS is a threshold-driven feature. The moment a data store violates its threshold, and these thresholds are configurable by default, it's at 50 millisecond latency for I/O load and 80% space utilization. The moment it violates these thresholds, Storage DRS will trigger a migration recommendation. Now, it's different for I/O load than for space utilization. The primary focus is on space utilization because we don't want to have out of space because that will generate a denial of service of your virtual machines, right? So the moment a data store violates its space threshold, Storage DRS will start to generate migration recommendations. And depending on your automation mode, you either apply it manually or vCenter will take care of it. Now for I/O load, we have something that's called a invocation period. So every 8 hours, Storage DRS is triggered. Same thing with DRS, that happens every 5 minutes. And it will start to look at the load of your data store cluster. Now, one thing you don't want to have with I/O load is that you are being triggered on peaks, right? So you don't want to load balance when there's a spike occurs. So what happens is that Storage DRS will use data that's of 16 hours of the current day. And that's the most important part to understand, of the current day. So I've created this diagram. And in this situation, we started to enable Storage DRS exactly at midnight to make it a little bit easier. Now at 8 o'clock, Storage DRS doesn't have enough data because 16 hours haven't occurred yet. Now at 4 o'clock, it has enough data. So at that point, it starts to generate migration recommendations, but only if the threshold is violated on I/O load. At 12 o'clock, that's a cutoff period because it's actually the new day, right? So what happens at that point is that all the statistics of the previous day are rolled up into a performance snapshot and is used by Storage DRS to take a look at the load. At 8 o'clock next day, the same thing happens. It doesn't have that 16 hours of data, right? So it uses the previous day statistics. And at 4 o'clock, it has new data it can use. So at that point, it starts to load balance again. So in essence, you can say that storage DRS will only load balance on I/O once a day. Now there are the reason why we still use 3 invocation periods is because there are some issues like connectivity that is happening during an invocation period. So, and we will come back to that later. So we start to use 3 times to actually help you get the most migrations along the day, to spread it across the day, basically. Now, when we see that a data store is violating its threshold, it will start to select virtual machines to become candidates for migration. Now, how does Storage DRS pick those virtual machines? It will look at the workload modeling and the device modeling. And what workload modeling is the active I/O load of a specific virtual machine. So it will start to look at all the workloads of the virtual machines on the data store. It also looks at the performance of the disk. So what it does is that it will try to mix and match performance of the devices with the demand of the virtual machines. So when a virtual machine generates a lot of I/O load, it needs to be placed on a data store that has a low I/O load to have the best performance, basically. Now, once it has a overall perspective of these 2 things, it's going to do a cost-benefit analysis. So what will it cost me to move this particular virtual machine to that data store, and how will it impact the overall load balance of my cluster, right? So this is called so the cost is the number of megabytes being moved, while the benefit is the overall improvement of your load balance. Hold on, go back.
Hold on, yeah.
Question.
Yeah.
Is there a way we can configure with the 16 hours?
No. So the question was, can we configure the 16-hour stats? And it's not possible at this moment.
No, but you can configure the invocation period.
Yeah,
so
but that does not impact.
No. No, Frank explained the invocation period is every 8 hours, but you can configure the invocation period, like have it every 4 hours or have it every 10 hours. But you can't configure the 16 hours.
Only trigger every 16 hours.
Yeah. Nah, it will only you.
Let's take this offline, right?
Good question.
Yeah. So in essence, Storage DRS tries to load balance every day on I/O load balancing, on I/O load, while an out-of-space occurrence will trigger Storage DRS whenever that occurs, right? Affinity rules. I assume you're all familiar with affinity rules in DRS. Same thing is available in Storage DRS, but only this is based on the files of a virtual machine. Now, VMDK affinity rules will force Storage DRS to keep all the files and disks of a virtual machine on one particular data store, while the anti-affinity rule will force DRS to spread it out across the data stores. The VM to VM anti-affinity rule, it's kind of special because it forces a subset of virtual machines on different data stores. Now, it needs to use VMDK affinity rules to keep the virtual machines, the files of that virtual machine on one data store. You cannot use an anti-affinity rule together with a VM to VM affinity rule, because you might end up with a situation where it cannot place all the files on all the data stores, right? So for instance, when we have 2 virtual machines and each virtual machine have 4 VMDKs, so in total you need to spread those 8 VMDKs on 8 data stores. But what if you have only 5 data stores? So for that particular reason, you need to use an affinity rule on that virtual machine. So that virtual machine is on data store A, and the second virtual machine with all its files is on Datastore B.
All right, so let's shed some light on the Datastore cluster construct. So what we wanted to highlight is how is a Datastore cluster design influencing your environment? So what do you have to take care of? And we want to highlight a few things like, you know, the connectivity things, the Datastore sizing within a Datastore cluster, how your virtual machine design may influence a Datastore cluster. But the main thing I want to highlight especially is always think about your solutions in your data center. So the keyword is solution interoperability. So Storage DRS is at the moment not compatible with SRM. So if you are using SRM in your environment, you cannot use Storage DRS because the recovery plans of SRM are not aware of storage migrations. So the good news is we are consistently enhancing this feature. So it wasn't compatible with vCloud Director with 5.0, but with 5.1 and the new vCloud Director, it's fully supported with Storage DRS. So we are very confident and we are always trying to enhance this feature that it will work in the future also with our other solutions. Now, I mentioned connectivity. Now, recently a customer of mine asked me, so we have a lot of arrays, so what's the best way to set up our Datastore clusters? And we came up with creating for each array a single Datastore cluster, and then we connected all these multiple Datastore clusters to their DRS clusters. Much like you see on the left graphic, like one DRS cluster connected to multiple Datastore clusters. This is fully supported and perfectly okay. On the other hand, if you don't have the need for creating multiple Datastore clusters, you can also create a single Datastore cluster, giant Datastore cluster, and connect multiple DRS clusters to it. So there is no need for a one-to-one relationship. You can mix this as you want and as it fits your environment, of course. However, the boundary of a vMotion is still the DRS cluster for a VM. So Storage DRS will not migrate a VM across DRS clusters, or so this is still not possible with Storage DRS. So whatever fits your environment, whatever configuration you are going to do, we are confident that Storage DRS will support this in terms of connectivity.
So what happens is basically when you trigger a vMotion, or when DRS triggers a vMotion, it only moves the compute level of that virtual machine. So it always leaves the virtual machine on the same data store. Storage vMotion is the exact opposite. So it moves the files of a virtual machine, but always leaves the virtual machine on the host, right? Now, you may have heard in the keynote the enhanced vMotion, where we now don't have the requirement of shared storage anymore. Storage DRS does not leverage that technology as of now. So you cannot vMotion enhancements, or cross-host vMotion if you like to call it, is always a manual task. It's always triggered by the administrator. There is no feature at this moment that leverages that technology in an automatic way. Okay. Now, when we talk about designing your Datastore cluster, one of the questions I had was, I don't connect all my data stores to my hosts. And this is what we call a partially connected DRS cluster. When you enable Storage DRS, it actually takes over the responsibility of initial placement from DRS as well. So Storage DRS will decide where to place the virtual machine on the host and on the Datastore cluster level. The reason why it does it is it wants to guarantee the highest mobility of a virtual machine. The moment a host is not connected to all data stores, we have a problem with load balancing it on the Datastore cluster level and on the DRS level. If a virtual machine is placed into a data store that's partially connected, and you're just moving that data store into your data store cluster, and that's perfectly normal. You can always move a data store with existing virtual machines in your data store cluster. You do not have to empty it out before moving it in, right? If that occurs, you might see the impact on compute level distribution, right? Because we cannot move virtual machines to hosts that don't have that connection, right? So please keep in mind and please try to apply the best practices of connecting all hosts to all data stores in your data store cluster. Now, like Valentin mentioned, what if I have a lot of data stores spread across multiple arrays? Can I include those data stores into one data store cluster? Yes, you can. We fully support it. But think about the impact it has on the mobility and the impact of the lead time of vMotions. If you have an array that is VAI enabled, you will offload your migrations, which lead to a faster vMotion process. Now, Storage DRS can decide, oh, I'm losing my voice now. It's always fun. He can decide to migrate a virtual machine from one data store on one array to a data store on another array because of an out of space avoidance. And that data store is actually the best candidate for housing that virtual machine, right? Now, at that point in time, you cannot leverage VI anymore because VI is an internal array feature. So your vMotion process will take longer. What is the perfect use case for this? Usually it's like for the migration array process. So what I explained in the maintenance mode slide, span it across multiple arrays and then put the data stores put the data stores in the data store cluster and put it into maintenance mode. Right?
A nice add-on is you can always join any data store in a data store cluster, even if there are VMs on it. So it has not to be empty to be joined to a data store cluster.
Correct.
So
for the age-old questions, what do I use in Storage DRS, NFS or VMFS? Well, both are excellent formats. However, you cannot mix and match them in one single data store. When you do that, the UI will trigger an error message and it will not allow you to put an NFS data store in your data store cluster that contains VMFS data stores. Another question is, can I mix and match different VMFS types? VMFS 3 and VMFS 5. Yes, you can. We fully support it, although we recommend you to move to VMFS 5 as soon as possible because of the unified block size. That will have impact on your storage vMotion lead time as well. And an upgraded VMFS 5 can have still SCSI reservations, right? Now, when will you see a data store cluster with VMFS 3 and VMFS 5 data stores? Usually when you do a migration process of VMFS 3 to VMFS 5. Again, with the maintenance mode, use a VMFS 3 data store, put it into a cluster with VMFS 5 data stores, put the data store into maintenance mode, let Storage DRS move it out, take that data store away, reformat the data store, put it back in, right? And let Storage DRS, during invocation periods, load it up again. So I already told about ATS. So the question is, should I upgrade a VMFS 5 data store or should I format a VMFS 5 data store? When you upgrade a VMFS 3 data store, you will always keep your block size. Like I said, this can impact the lead time of a storage vMotion when you migrate a virtual machine from a data store with a 2 MB block size to a 1 MB block size. Also, upgraded data stores can fall back to SCSI reservations. And a reformatted data store always uses ATS. I listed that knowledge base article. Please check it out for more information.
So, all what you just have heard, just leading to think about your environment when you're designing your data store cluster. Think about your volume sizes, your VM sizes. It is recommended to lead to a standardized design, like standardized sizing within a data store cluster. So why are we recommending this? I got the question, can I mix multiple sizes of data stores in one data store cluster? Technically you can, it's supported, you can do that, but there comes a catch with it. So Frank told us about all the thresholds, like space avoidance threshold and the I/O load balancing thresholds. Now those thresholds are applied on the cluster level, not on the data store level, on the cluster level. So let's assume we have 85% space avoidance. So we have 15% slack space, where Storage DRS triggers a migration if a data store is higher utilized than 85%. Now, if you have two different data store sizings, like 1 terabyte and 500 gigabytes, 15% of 1 terabyte is entirely different to 15% of 500 gigabyte, right? So when you decide to use different sizings in one data store cluster, this may lead to unnecessary migrations because of the percentage value. So that's why we recommend using standardized sizing and think about how is my biggest VM, can it fit on my data store sizing? And when this is true, just create a data store cluster where you use your standardized VMFS sizes.
So one thing that can have impact on your data store size as well is the affinity rule, and we will we will expand on that later. But the default affinity rule of your data store cluster is a VMDK affinity rule. So if you have really large virtual machines and they exist, and in that virtual machine it has multiple VMDKs, you might want to think about using a VMDK anti-affinity rule so it can spread out. You don't have to have that big data store, right?
Right. So the other thing is extends. So a few customers of mine using extends and asked me if they can use it with data store clusters. And extends is all about growing your storage space, like adding additional storage space to a VMFS volume. Now you can use them in Storage DRS, that's supported. However, there comes also a catch with it. You cannot use I/O load balancing with it, because I/O load balancing is based on SIOC, and SIOC does not support extends. So initial placement can be used. You can use it for having the data store cluster construct, but you cannot use load balancing with it. However, when it comes to adding space, Storage DRS is also providing this functionality quite easily, because you can just add another data store to your data store cluster to expand your space. And by this, you enhance storage DRS, because it gets more options to choose from. It gets more data stores, so it can do a better load balancing, depending on your affinity rules, as Frank already pointed out, of course. But adding more data stores to a data store cluster always leads to a better load balancing of your Storage DRS cluster. Now,
let's take a look at the impact of virtual machines, right? So one of the questions is, can I use thin disks in my data store cluster? And yes, you can, and we actually recommend you to take a look at it, because Storage DRS is thin disk aware. And for example, when it does the cost-benefit analysis, it will actually look at the footprint of the existing virtual machine. So instead of using the whole provision space, let's assume that a virtual machine has a provision space of 20 gigs, but it's actually using 5 gigs. It will use those 5 gigs for its cost-benefit analysis. So it will know that to move this virtual machine, I only need to move 5 gigs, right? So it's more efficient that way. Now, when you place a virtual machine on a data store, for instance, when initial placement or load balancing, Storage DRS will look at the existing thin disk provisioned virtual machines on that data store, and it will look at the growth rate of those thin disks. So it knows, so it's aware that a thin disk is not a static entity. it can grow during the storage vMotion. But it also can grow within the next invocation period. So it takes the growth rate of that virtual machine and adds it to the footprint. Now it looks at the new virtual machine, the candidate virtual machine, and it will calculate that what impact the placement of that virtual machine plus the growth rate and the footprint of the existing virtual machines is. And if that exceeds the threshold within the next 30 hours, it will back off. It won't make that recommendation. Right? So you don't have to worry about thin disks growing or when they have an active growth already, so that you're going to ping pong virtual machine placement around. So every time you place a new virtual machine and those virtual machine will grow beyond the threshold, Storage DRS has to replace it. It uses those 30 hours as a buffer time space, basically. So let's take a closer look at initial placement. So when a virtual machine is placed, it will look at the disk footprint. Now in this version, we are looking at the provision space. So even when you have a thin disk as a disk size, it will look at the overall space because it cannot really know what the actual footprint is, right? It also looks at the affinity rule. Do I need to place all the disks of this virtual machine on one data store, or can I spread them across data stores in my data store cluster? When selecting a data store, it will look at the free space of the data store, and it will also look at the I/O load of the data store. Now, even if you have disabled I/O load balancing, it will look at the average I/O load of a data store. So when Storage DRS has like 3 data stores as candidate destinations, it will take the data store that has the lowest I/O load. So it always it always tries to get you the best performance for your virtual machine, right? Now what happens if you want to place a virtual machine on a data store cluster that has enough free space, but each individual data store doesn't have that space, right? So in this case, we are trying to place a VMDK 350 gigs. Now what happens is that Storage DRS will trigger what we call defragmentation. And it starts to move out virtual machines to make place for that particular new virtual machine. Now in this scenario, which is in this diagram, it moves 2 virtual machines out of data store 1. It moves it out to 2 different data stores, but we consider this as a single step. Now a step is something that is a collection of migrations out of a single data store. And in this particular case, we are actually moving a virtual machine into the previous data store that we are actually offloading. Now the reason we did the first step was to actually make room for the second virtual machine to place on data store 1 and not violate the threshold, and then move and then place the new virtual machine on data store 2. Now to avoid having a migration storm, it's limited to 2 steps. You can change this into a maximum of 5 steps, but we do not recommend this because a step is basically, in the worst case scenario, it can move out all the virtual machines of a single data store. So within a step, you're not limited by the number of migrations of virtual machines. So having a 5-step configuration, that can lead to a migration storm, right?
So I'm really delighted to present this slide because Frank and I had a short discussion because this is, apparently it's one of his babies. So Frank is responsible for getting this into 5.1. So what I'm talking about affinity rules. And Frank already mentioned this a few times. And normally your storage DRS cluster has a default intra-VM affinity rule, which is like keeping all the files of a VM together. Now with vSphere 5.1, and thanks to Frank, you can change this now by ticking off the checkbox saying keep VMDKs together by default. So it will change into an NT-VM affinity rule, VMDK. So let's shed some light on the intra-VM affinity rule first. So what it basically does is it keeps all the VMDKs and files of a VM together by creating a so-called artificial atomic level. And the artificial atomic level is the smallest entity Storage DRS can migrate. So in this case, a VM with 350 gigs, Storage DRS needs to find a data store with 350 gigs of space available, and also a data store which fits in regards to the I/O load. Now, when this VM gets placed on a data store and the data store is violating any of its thresholds, Storage DRS needs to migrate the whole VM to another data store in case. So this really limits Storage DRS in its functionality from balancing out in a real atomic level. Now, what is the real atomic level?
Can I add something?
Sure.
So when you take a look at this diagram, you actually see that this virtual machine uses multiple disks. Now, it can be that disk 1, and I assume it's disk 1 is always the OS disk. Maybe the third disk is an high I/O load disk, so maybe that contains the data store of the database of this virtual machine. Now, when you enable I/O load, it will need to provide the data store that can handle the I/O load generated by the virtual machine. So what happens if one of these disks is a high I/O load generating disk while all the others are idle? How does Storage DRS decide to place it? Now, in this scenario, Storage DRS needs to move that virtual machine to a data store that can actually accommodate the I/O load for that virtual machine. It means that all the other disks do not really take use of that performance. Now, the data store has a finite size. So in essence, you're creating some sort of denial of service on other high I/O load virtual machines, because the Storage DRS cannot place those virtual machines on that data store because there are other files already in place that do not really need that I/O load, right?
Right, so what is the real atomic level of Storage DRS? So this is the DRM disk. So the DRM disk can contain all the VM files or the VMDK of the VM, including their snapshots. And those are really the smallest entities Storage DRS can migrate across data stores. So let's have a look at the anti-affinity rule, where Storage DRS can place each DRM disk individually on a separate data store. Now, when we come back to the example of the VM with the 350 gig, Storage DRS does not need to find a data store with 350 gig available. It just needs to find data stores which can house each of the VMDKs. And so it can spread the VM across the data stores in your data store cluster. And coming back to Frank's example, if there is a disk demanding high I/O, and if there is a threshold violated for the data store, Storage DRS can individually treat each DRM disk and place it on different data stores, which leads to a much better mix and match. So you get a much more balanced cluster by enabling Storage DRS to use the real atomic level by enabling the VMDK anti-affinity rule. It may lead to a more difficult troubleshooting scenario, but you get really more I/O load balancing and more space balancing out of it by using this affinity rule.
Yeah, so in our previous session, we actually had a question. So how about snapshots of a VMDK? Is that a separate DRM disk? And the answer is no. When you have a snapshot, it's always included in the same DRM disk as the VMDK itself. So when Storage DRS decides to move a VMDK and it has a snapshot attached to it, it will move that snapshot with it, right? Question?
What if the VM has an affinity rule set to keep the
that the VMFS is say 2 terabytes, but the VM exceeds that amount of requirement.
So when the question is, if I understand you correctly, when I have a virtual machine with an affinity rule, right?
Yeah.
And now it needs to place somewhere else?
Yeah,
You got it?
I think the question is, what if I have a VM with multiple disks exceeding the size of a data store?
Exactly.
And you have the affinity rule in place, like place all the files on one single data store.
Yeah.
So you cannot place it in your data store cluster.
Exactly.
Yeah, that's the outcome.
So
you have to disable storage DRS to place it.
But the affinity rule is always something that's a hard rule. That's a mandatory rule. Storage DRS cannot violate that.
But you can change it.
There's one advanced setting for that, and that's for maintenance mode, data store maintenance mode. We have an advanced setting that can say disable affinity rule for maintenance mode. So I will write a short article on that on my blog pretty soon.
Yeah, but in this case, you would have either choose a different affinity rule or disable storage DRS.
Now let's take a closer look at load balancing itself. Now in this scenario that we have 2 data stores into a single data store cluster. And data store 2 is actually violating its threshold. So storage DRS will do a cost-benefit analysis on the existing virtual machines on the data store. And it has selected VM3 to move to data store 1. Now, in this scenario, data store 2 will drop down its I/O load to 30 milliseconds. So it doesn't exceed the threshold anymore. Data store 1 went from 5 milliseconds to 12 milliseconds. Now, in the previous example, VM1 was really happy on a data store with 5 milliseconds latency. And now VM3 comes along and will basically take away some of his performance. The question I received was, will storage DRS start to look for a data store that has a 5 millisecond latency for VM1, because you're using a workload model and we know what the virtual machine is actually experiencing when it comes to I/O load. And the answer is it doesn't. Storage DRS will not move VM to another data store, because overall, in this case, the data stores do not violate the threshold. And DRS is thought that if the data stores do not violate the threshold, we provide you with the best overall experience. So a move will benefit the society, right? Every move takes up compute cycles, take up network cycles, basically network load, either on fiber channel or on Ethernet. So moving our virtual machines will incur cost, will incur overhead, will incur risk. If there's no reason to do it, we're not going to do it anyways. Now the interesting part is we introduced in 5.1 something called data store correlation. The moment storage DRS figures out that 2 data stores are backed by the exact same spindles, we do not generate I/O load recommendations for these data stores. Because if we start to move virtual machines from data store 1 to data store 2, but they are backed by the exact same spindles, that move will not generate any difference from a performance perspective. Keep in mind, this is only for I/O load balancing, because if data store 2 is actually violating its space utilization, we're still going to move it anyways, because we do not want to have an out of space scenario, right? Now another question I received was, I have an array and I have a couple of tiers. I have some disk groups with SATA in it, and I have some disk group with fiber channel in it. Can I create those? Can I use those disk groups and place them into one single data store cluster? There's no technical inhibitor for it. You can do it. However, we do not recommend you to, because in certain scenarios, while I/O load will not move that virtual machine to a data store backed by a slower performing disk group, when we have an out-of-space avoidance, sometimes we need to move it, right? Because that's the only data store that can handle the space of that particular virtual machine. So in that case, we do a trade-off, I/O load versus space utilization. This can lead to some questions from your customers why the performance just took a dive. And that's one of the primary reasons that we say use similar types of disk backing your data store cluster.
Now,
sorry, question.
What about a fast VP or a fast policy?
I will come to that later on.
yeah, we'll cover it within the next slide. Now, also questions we get is, can we use storage profiles with Storage DRS? Yes, you can. There are pretty good examples for it. One is, I want to especially highlight, for instance, if you have multiple sites, my customers do, and they normally have a special naming convention, special naming for their data stores to identify the site where it comes from. So for instance, they call it storage vendor-101 for site A and storage vendor-201 for site B. Now, this makes sense, but it can be pretty challenging to choose the right volume out of the lists. I mean, if you have only 10 data stores, it's not much of a challenge. If you have about 200, it can be compelling.
Yeah, think about the resource aggregation part.
Yeah.
When you have a data store cluster, you don't see your data stores anymore.
Yeah,
you only see a data store cluster name. So you cannot figure out what kind of performance of what kind of site that data store is in, because you only see the data store cluster name, right?
And Storage DRS is not aware of the origin of the data store. So Storage DRS does not know if it comes from array A or from array B or from site A or from site B. So this is where storage profiles kicks in and can handle this for you. So you can create a storage profile containing all the data stores of site A, and with those data stores you build a data store cluster. And you do exactly the same for site B. And if you now provision a VM, you can just pick the storage profile, and storage profile can have the name of the site, like site A. And then it will only show you the data store cluster which is compatible with site A, which contains all the data stores in site A. So it is easier to deploy a VM, and it leads to a smaller scale decision, and it's another abstraction layer which makes your life basically easier, and which prevents errors like they selected the wrong data store, things like that happens all the time. So by leveraging storage profiles, you can really add some benefit to this, and you can really ease up your whole deployment process.
Yep.
So now to your question.
We've got 4 slides for your question. So,
Yeah, we hope that fits.
So what about using storage DRS with arrays that have particular technologies like fast, like auto-tiering?
Just by show of hands, how many of you are using auto-tiering arrays today?
Okay.
All right, interesting.
And how many of you are looking to use I/O load balancing in your storage DRS cluster? Mm-hmm. Okay. Okay. Now, to understand the performance of a device, I mentioned that we use device modeling. Now, how exactly does device modeling works? Storage DRS uses SIOC, the SIOC injector for it. And it will open up a block, and it will generate outstanding IOs. And it will increase, it will start off with 2, then go to 4, then go to 8, to 16, to 32 outstanding IOs. And it will look at the latency of those blocks. We only do that when the data store is actually lowly utilized. The moment the data store is hit with workload, the SIOC injector will back off. So it does not impact normal workloads, right? So because it's a fairly intensive operation, it's not going to open every block on your data store. It will open random blocks, right? And if you open up a specific amount of blocks, you get a statistic meaningful value. Now, let's take a closer look what happens with the decision matrix of I/O load balancing. So in this scenario, this data store is being backed by 3 tiers, SSD, fiber channel, and SATA. Now in this scenario, the SIOC injector starts to open more blocks on the SATA devices than on all the others. With the outstanding I/O and with the latency, Storage DRS thinks, okay, this is a low performing data store. Now it uses that model when it needs to place a virtual machine. So high I/O load virtual machines won't be placed on that because it's not a perfect match, right? Now in reality, as you see with the blue blocks, most blocks of that data store is backed by SSD. So our device modeling is completely off, right? Now, let's go to auto tier. Let's go to fast or any other technology. In this scenario, we are actually doing a great job. The orange blocks or the yellow blocks will show that we opened up and we read more blocks on the SSD devices than on all the other devices, right? Now, our device model is correct in this time. Now the problem is, our invocation is each 8 hours. And with the 16 hours of current day data, that only occurs at 4 o'clock in our scenario. But the auto tiering solution happens to move blocks every minute, if it wants to. If it wants to offload, if it wants to move idle blocks to a lower tier, right? So in that scenario, our device model is off and we're actually going to recommend a high I/O load to that particular data store, while in reality, that data store is now backed by fiber channel disk, or even worse, maybe SATA disk. So there's a mismatch again. Now, the problem is, Storage DRS is not aware of what the array tiering solution is doing, and the array tiering solution is not aware what Storage DRS is doing. So we have 2 captains on one ship that don't communicate with each other. And for that reason, we recommend you to set it to either to manual mode, I/O load balancing, and so you can provide and commit the migration recommendations yourself, or if you don't want to, set it to disabled. Just disable the I/O load balancing feature at all, right? Now, this is just one part of array technology. We can talk about deduplication, we can talk about replication. Duncan Epping and I wrote a white paper on the interoperability with storage array features and with other VMware array solution features, and it's available on the VMware website. So please check that out if you're interested in all the other ones. So this is the end of our session. We left some time off for open mics. So if you have questions, please use the mic.
We really appreciate that you're all here at this early time.
Yes.